Hey everyone, in this video we're going to go over all of the answers to the first semester review. So please just follow along with your paper, get your paper out that you submitted and go along with each one and make sure that you understand how it's done correctly and that you can make the corrections on your own. So let's start with the first one. You're supposed to find the limit as x goes to 0. So as we approach 0 from the left side and the right side, they have to be the same in order for the limit to exist. So as we approach from the left, we're going to trace in the function this way. It's going to 0. The y value is approximately 0. And as we come in this way from the right, the y value is 1. So the left would be 0, right is 1. Those are not equal, so we would say the limit does not exist. For the next one, when we're evaluating a limit, the first thing that we want to do is just try to plug it in and do direct substitution. So we're just going to substitute 1 in for all of the x's and see what we get. In this case, we get 0 over negative 2. That is okay because 0 over a constant is just 0. That'd be our answer. If we had gotten 0 in the denominator, then we would have to manipulate that in some way. Okay, for the next one, this is a piecewise function. We're asked to find the limit. So with the piecewise, you want to still plug it into the left and the right and see if they're equal. In this particular function, we're given this function for numbers not equal to 1. So that would be any number that's less than and greater than. So for both the left, as x goes to 1 from the left, and the limit as x goes to 1 from the right, we would actually just plug it into the top function. We're going to plug in 1 into the top function. So we have 1 squared plus 4, which would be 5. And in the bottom, we plug it into the same function, so we get 5 for both. It does not matter the fact that the value at x equals 1 is 2. It means there's a little jump discontinuity there. That doesn't matter. We're asking about the limit. So the limit, since these are the same, would then be 5. For the next one, we're going to start by just trying to plug it in at first. You will see, though, however, when you plug in 1 into the denominator, you get 0. So that's not going to work. The next thing we probably want to try to do is factor this, see if we can get something to cancel. So the top is going to factor into x plus 2 times x minus 1 over x minus 1. And we will get the cancellation we're looking for. Those cancel out. Leave this with then just the limit as x goes to 1 of x plus 2. We can now go ahead and just direct substitute, plug in the 1, so we get 3. For number 5, we would again try to just plug it in. However, when you plug it in at the bottom, you get 0, which means we need to do something else. Anytime you see a square root, you're probably going to want to think rationalize. So in this case, to rationalize means to multiply by 1 plus square root of 2x squared minus 1 over 1 plus square root of 2x squared minus 1. We do that, just like multiplying by 1. That's why we're allowed to do it. On the top, when we FOIL that, the first 1 times 1 is just going to be 1. The two middle terms are going to cancel because we have a minus radical 2x squared minus 1 and a plus radical 2x squared minus 1. So the middle terms cancel out. We don't even need to write those. But then when we do the last terms, the radicals is going to be minus. If you do something in a radical times itself, the radical just cancels and leaves us with 2x squared minus 1. On the bottom, we're just going to leave it as is right now, x minus 1 times 1 plus the square root of 2x squared minus 1. At this point, we would want to try to go ahead and plug it in again. However, when we do plug it into the bottom, we still get a 0 and then a 0 times. So when we plug it into that first term, 1 minus 1 would be 0. That would make the bottom 0, so that's not going to work still, which means we do need to still try to get some cancellations. And what you'll see what happen when we combine the like terms on the top, we get negative 2x squared when we distribute that, and that becomes plus 2. The bottom would still stay the same, so I'm just going to write that for now. We then want to factor the top. When we factor the top, it would become, we can pull out a negative 2. It leaves us with x squared plus 1. Bottom is still the same. We then can factor the top into x plus 1 and x minus 1 over, now let's go ahead and write the bottom again, x minus 1 times 1 plus the square root of 2x squared minus 1. And then you can see the x minus 1 and the x minus 1 cancel. So then what we're left with is negative 2 times x plus 1 over 1 plus the square root of 2x squared minus 1. We then can go ahead and plug in that 1. So we got the limit still here as x goes to 1. We can go ahead and try to plug that in now. When we do that, we'll get negative 2 times 1 plus 1 is 2 over 1 plus the square root of 2 times 1 squared, which is 2 minus 1 square root of 1. So we get negative 4 over 1 plus square root of 1 is 2. So we end up with negative 2 as our answer. Now there's a lot involved in that one, but it is doable. Just go through the math steps there. So negative 2 is our answer to number 5. All right, number 6. We're supposed to find the limit of each of these. So we're approaching 0 from the left, 0 from the right. And I think it's, yeah, this is one I think I told you to correct. That shouldn't be there. That little plus sign there. So on the first one, the limit from the left, that's going to be numbers less than 0. So that's going to go in the top function. So when we plug 0 in the top function, we get 0 squared plus 1, which is just 1. Limit from the right is going to be the bottom function because those are numbers greater than 0. So that's going to be 2 times 0 minus 3, which is negative 3. So A and B is 1 and negative 3. And then the limit overall, well, since these are not equal, the limit would be D and E. For number 7, you're supposed to find the values that make this discontinuous and label these discontinuities as removable or non-removable. Removable you can think of as a hole, whereas you can just sort of fill in that hole and it makes it continuous. A non-removable would be something like an asymptote. So what we need to do to figure these discontinuities out, the discontinuities always occur at the zeros of the denominator. So if we were to factor that denominator, we'd factor into x plus 2 and x minus 2. On the top, we got the x minus 2. So then from here, we can figure out if they're removable or not. They're removable if they cancel, sort of you can remove them from the function. So you'll see that the x minus 2's can actually wipe each other out. So that means that x minus 2 is the removable one, which translates to x equals 2. So x equals 2 is removable because we removed it out of there, right? And then this one, when you solve it, the x plus 2, that equals x equals negative 2. That is a vertical asymptote, which is a non-removable. So those are your two discontinuities, 2 and negative 2. But since the 2 cancels out with the top, it's a removable. And since the negative 2 does not cancel out, that makes it a vertical asymptote. It's non-removable. Can't remove it. Okay, the next one, we're asked to first do a composition, f of g of x. So for that, we take all of g and we plug it into the x and f. So f of g of x will then be 5 over x to the 4th minus 1. It's the first part, part A. We're then supposed to figure out all the values that make this discontinuous. So the discontinuity is going to be the zeros of the denominator. So that equals 0. X to the 4th equals 1. The 4th root of both. Just remember when you do this, if it's an even root, you're going to have the plus and the minus root. So it is plus and minus 1. We don't have to label them as removable or non-removable, but these would actually both be non-removable because they don't cancel. So there's your two answers. Let's go up to number 9. Determine the value of c such that the function is continuous on the real line. So if a function is continuous, that means that keep in mind the definition of continuity. It's that the limit as x goes to c from the left equals the limit as x goes to c from the right, which implies that the limit exists. That's our first condition. The second condition is that f of c is defined, meaning that the function is defined at that point. And then the last condition is that the limit as x goes to c equals f of c, so that the limit equals the function value. So keeping that in mind, we want this thing to be continuous. So in other words, this would be sort of the limit. You can think of this because that value is less than, will be the limit as x goes to some c value from the left, let's say from the left, and the f of c. And then this one is greater than, so it would be the limit as x goes to c from the right. So if this thing is going to be continuous, we know that these two must be equal to each other. So we simply just set x squared equal to c over x. And solve it. Now, the particular place that we're looking for these to be equal is at 3, because that's where the only break occurs. So this would be 3 squared equals c over 3. We then solve it. We get 9 equals c over 3. So c is 27. For number 10, the first thing we'd want to try to do is plug in 3. When you do plug in 3, you get 9 minus 18 plus 9, which implies that it does give you 0. All right, so we need to do something to it. The only problem is when we factor this thing, it's not going to help us a lot because, well, that 3 on the top isn't factorable. It's not going to cancel with any x's. So what I would recommend on this one is use a table. It's another method that we learned. Remember, with the table method, you plug in values really close to 3 from the left and the right side. So you can plug in x values like 2.9, 2.99, and then so it'd be values a little bit less than, and we could even do 2.999, and then values a little bit greater than would be values like 3.01, 3.001, so we should get a 3.1. So if we plug those in, what I would do is just plug those into your calculator. Just plug the original function into your y equals part, and then do your second table. When you plug in 2.9, you get 300. 2.99, you get 30,000. And 2.999, 3e to the 6, so we get like 300,000. So this is clearly going to positive infinity, which that actually already tells us that the limit does not exist. And if we did a little bit greater than, let's say we did 3.1, write that down. 3.1 is 300. 3.01 probably going to be 30,000. Yeah, so same deal. 30,000, 300,000. So both of these are going to positive infinity. So sometimes you'll see that the limit as x goes to 3 equals positive infinity. But the actual correct way of saying that would be does not exist. Either of those would be acceptable answers, though. It's going to positive infinity or limit does not exist. This is the best answer, limit does not exist, because infinity does not exist as a value. It is more of a concept. All right, the next one is vertical asymptotes. So vertical asymptotes of this function. Remember, vertical asymptotes are the zeros of the denominator that are not also zeros of the numerator. So we just do x plus 7 equals 0 and solve it. We get -7. That makes the bottom 0. Now the only thing is we just need to make sure -7 is also not a 0 of the numerator. You could, if you try to factor the numerator, you're not going to get very far. The easiest way to just figure this out is just plug -7 into the numerator and make sure it doesn't equal 0. We get 49 minus 21 minus 1. It's definitely not 0. It's not equal to 0, so that means we're good with this. If we had been 0, then we would just cancel it out and say there's no vertical asymptotes. Okay, for the next one, we want the zeros of the denominator that are not zeros of the numerator. This one looks like we should go ahead and factor. Factor the bottom, it would factor into x plus 3 and x minus 2. The top factors into x minus 2 and x plus 1. The x minus 2's cancel. So that tells us there's actually a hole there at x equals 2. And that means the only remaining thing left in the denominator would be x plus 3. So that equal to 0. So x equals -3 would be a vertical asymptote. Okay, next one, number 13. At each point indicated on the graph, determine whether the value of the derivative is positive, negative, 0, or the function has no derivative. This is a little bit more challenging because the curve isn't as clear as I would like it to be. But let's just go with it here. Now the derivative, remember, as we're getting into derivative now, derivative is basically the slope of a tangent line. It's one definition of the derivative. So what I want you to think is, what would the slope of the tangent line be at these points? At this A here, it's kind of hard to tell, but it's a sharp point. Anytime you see a sharp point, the limit will be does not exist. Because you can't really make a tangent line on that point. It's kind of hard to explain, but basically anytime there's a sharp point, the limit does not exist. For B, the tangent line would look like this. And so that is going to be a negative tangent line, right? It has a negative slope. So for B, it's negative. At C, this one is more rounded. Again, it's kind of hard to tell. It's rounded. The tangent line would actually just look sort of like that. There would be a horizontal tangent line, which means that the derivative would be 0. Slope is sort of 0 at that point. At D, it's going to be a positive tangent line. Basically, we're just looking at the slope of these lines, right? So that's positive. And at E, it is again going to be 0 because it is more of a rounded one. So the slope of the tangent line looks like that, and that is 0. All right. Key thing here is the definition of a derivative. We all know how to calculate derivatives, hopefully at this point. So we know the final answer, f prime of x, is just going to be 2x, right? However, that's not going to suffice for an actual answer. You do need to use the limit definition. The limit definition looks like this. The limit as h goes to 0 of f of x plus h minus f of x over h. That's what the formula is that we're using. So when we do that, plugging it into this function, it's going to look like this. Limit as h goes to 0 of wherever we see this x here, we got to plug in x plus h. So it's going to be x plus h squared plus 2 minus the original function x squared plus 2. That's all over h. And then we just need to solve this. So when we do so, the first thing we'd want to do is to go ahead and FOIL that first term. That's going to give us x squared plus 2xh plus h squared. You do need to write it out as x plus h. If you can't do that in your head, write that out like that. And we still got that plus 2. And then we distribute this negative sign to get negative x squared and minus 2 over h. Now keep in mind when we're finished with this, the only terms that we want left are terms with a and with an h in them. That's the goal with these always. So the plus 2 and the minus 2 cancel. The plus x squared and the minus x squared cancel. So all we're left with here is the limit as h goes to 0 of 2xh plus h squared over h. At this point, since we've got all terms with h's left, we're going to factor out an h on the top. Limit as h goes to 0 of 2x, h times 2x plus h over h. We then can now cancel the h's. So we get limit as h goes to 0 of 2x plus h. Final step then is to then just plug in 0 for h. So we get 2x plus 0, which is 2x. Derivative. So you have to have all of that to prove that one. You can't just write the answer. Okay, number 15. For this one, we're supposed to find the equation of the tangent line when x equals 0. So in order to write a tangent line, you need a couple things. You need x value, a y value, and a slope value. So the first thing we're going to get is the slope of the tangent line. To find that, we're going to find the derivative, because the derivative is the slope of a tangent line. So f prime of x is going to be 9x squared plus 2. We just use our power rule there. And then we're going to plug it in for x equals 1. So we're going to do f prime of 1. 9 times 1 squared plus 2 gives you 11. That implies our slope is 11. We've already got an x value because it said x equals 1. So the last thing we need is a y value. The best way to do this is to just plug in the original one into the function. Sorry, yeah. Plug the x into the function, so f of 1. So 3 times 1 cubed plus 2 times 1. That gives us 3 plus 2, which is 5. So we got an x and a y equals 5. Now from here, you could take two options. You could either do slope-intercept form or point-slope form. I like slope-intercept form. We take our x, our m, and our y, and we plug them into y equals mx plus b. Our y is 5. Our m is 11. Our x is 1 plus b. Solve for b. 5 equals 11 plus b. So b equals -6. So our final answer then is y equals 11x plus 6. Sorry, minus 6. All right, next one. Find all points on the graph which has horizontal tangent lines. So first thing you need to think about on this is, well, how do we determine where a horizontal tangent line is? Remember, a derivative is a tangent line. If a derivative is horizontal means a slope equals 0. So what we want to figure out is where's the derivative equal to 0. F prime of x would be 3x squared minus 3. Set that equal to 0. Just solve it. We get 3x squared is 3. Divide that, x squared is 1. So then x equals plus and minus 1. And I guess it does say points, so technically you could actually go ahead and find the points by finding the y values. So f of 1 would be 1 cubed minus 3 times 1. So 1 minus 3 would be -2. And then f of -1 would be -1 minus 3 times -1, which would be +2. So we'd have 1 comma -2 and -1 +2. All right, next one. Position function for an object is s of t. S is feet, t is in seconds. Find the velocity of an object at t equals 2. So the thing that you need to know on this is that velocity function v of t is equivalent to the derivative of the position function. So first thing we need to find is the derivative of the position function. That would be 12t plus 240. And then we need to find it at 2. So we just do v of 2, plug it in, 12 times 2 plus 240, which would be 24 plus 240, which would be 264. And the units on that, looks like we had feet in seconds, so feet per second. For 19, we're supposed to differentiate. This one is going to use two rules. It's going to use a quotient rule, and then it's also going to use a chain rule. along with the power rule. I guess you could really say 3 rules. Let me switch to a different color here real quick. All right. So the quotient rule, that's when we have a fraction. We do the derivative of the top first, so that's 2 times the original bottom minus 3x squared minus the original top times the derivative of the bottom. Now for the derivative of the bottom, we have to use a chain rule, which will bring the 2 down in front. So times 2, keep the inside the same, 1 minus 3x squared to the first power now, and then times the derivative of the inside, which is going to be just minus 6x all over the original bottom squared. So this thing squared. Probably should at least simplify this a bit. Keep the first term there, 1 minus x squared. With this other one, though, we could put all of these 3 terms together, because when you multiply, you can change the order, whatever order that you want. So let's see, that would give us a plus then. 2 times 2 is 4, times 6 is 24, x squared times 1 minus 3x squared over, now since this is a squared, it would just be the 4th power, so 1 minus 3x squared to the 4th. And then if you notice, all of these do have that 1 minus 3x squared in them, all 3 of these terms. So we can cancel this one out. There's one of them. We can cancel one of these, makes it 1. Then cancel one of these to make it 3. So it becomes 2 times 1 minus 3x squared plus 24x squared over 1 minus 3x squared to the 3rd. I suppose we then could multiply and combine some like terms on the top. That gives us 2 minus 6x squared plus 24x squared. So that would give us 2 minus 18x squared over 1 minus 3x squared to the 3rd. That's probably good enough. There. All right, and last one on the front page, we're supposed to find d squared y dx squared, in other words, the second derivative. So first derivative y prime, we got to use a quotient rule. So the derivative of the top first is just going to be negative 1. This derivative of 1 is 0, negative x just negative 1, times the original bottom, 2 minus x, minus the original top, 1 minus x, times the derivative of the bottom, which is just negative 1, over the bottom squared. We definitely want to simplify this a bit since we have to do another derivative. So on the top, we're going to get negative 2 plus x. And then on the bottom, this becomes actually a plus 1 times that. So plus 1 minus x over 2 minus x squared. Sorry, that's we're in the wrong spot. So on the top, this cancels and this cancels. Negative 2 plus 1 is just negative 1. So negative 1 over 2 minus x quantity squared. And then we can go ahead and do the second derivative now. So y double prime. And from there, you could actually do two different ways. You could do a quotient rule again, which maybe is the easiest way since it's already written as a fraction. Or you could actually rewrite this as just negative 1 times 2 minus x to the negative 2. That's probably a little easier actually, because you could just then do the chain rule. But either way, if you were so if you were to do this chain rule method, then the second derivative would then just be positive 2 times 2 minus x to the negative 3rd times negative 1, because that negative 2 would come down in front. Keep the inside the same, subtract 1 from the power. And then so this would be rewritten as negative 2 over 2 minus x cubed. The other way would be to use the quotient rule, which would be the derivative of the top, which is just 0 times 2 minus x quantity squared, minus the original top, negative 1, times derivative of the bottom, which would be 2 times 2 minus x to the first power times negative 1, all over 2 minus x to the 4th. So we got to square it. When I simplify all that, the first thing all just goes to 0. On the top, looks like we got 3 negative signs, so that would become negative 2 times 2 minus x to the first power over 2 minus x to the fourth. We then could cancel out this one with one of these, change it to the third. So we get negative 2 over 2 minus x to the third, which is the same answer as we had here. So either way, get you the same answer, but it does work out a little bit easier to just rewrite it and use the power rule there. All right, we'll take a pause there and start up again.